Welcome, folks. We'll be starting in about a minute. All right, welcome, folks. Let's get started. Today is the 23rd day of remote learning, and today's joke is, why was Frosty the Snowman looking through a bag of carrots? He was picking his nose. Happy Monday. Simplify that like button to show your support for all the bad jokes. The YouTube channel featured in today's lesson is Numberphile. This channel has videos where research mathematicians, usually university professors, are talking about math that they find really interesting or math problems that they're working on, but they make sure to explain it in a way that you don't need a university degree in math in order to understand it. So the video that I've highlighted is one showing what happens when you put a fraction to the power of 2 and then add a constant number to it, could just another fraction, but always the same one. And then you iterate that process, which just means you repeat it over and over and over again. And some very different things can happen depending on what starting numbers you pick. So check it out in the lesson. Our lesson for today is that we are going to be working on optimizing rectangular area and perimeter. There's a handout in the Google Classroom post, and you'll want to have that open even if you're working on paper, but you might even find it easier for today to just work on the computer there. Following along with it will make it a fair bit quicker. All right, so let's jump right in. So the first thing is we have this word optimize because we are optimizing area and perimeter of rectangles. And so the question is, what does optimize mean? It means to find the optimum. What does optimum mean? It means the best. So when we are optimizing area and perimeter of rectangles, we are finding the best rectangle for a particular area and perimeter, or we are finding the best perimeter for a particular area or the best area for a particular perimeter. Rectangles. There we go. And so if you look at the handout, part one, we have an example where somebody's building a rectangle. And so this will explain a little more clearly what we mean when we say optimize. So in part one, we have a landscaper. They have 24 sections of fence, each is 1 meter long, and they want to enclose a rectangular garden. So Part 1A, on a piece of paper, sketch and label all possible gardens of perimeter 24 meters whose side lengths are all integers. So we're just going to use whole number side lengths for this. It turns out that what we figure out during this lesson applies regardless of whether you're using whole numbers. But for our purposes and to speed things up, we're just going to look at whole numbers. So if we have 24 sections of fence, we could go with a garden that is 1 section high. And you can see here I'm using gridded paper, so it'll help me out. And I happen to know this, and we'll talk about how I know it later. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sections long. One there, and then another 11 sections down this side. And so if we look at this fence, or this rectangle, we can see that it does indeed have a perimeter of 24 meters. And we can do that by just adding up going around. So 1 meter plus 11 meters plus 1 meter plus 11. Well, 11 plus 11 is 22, 23, 24. Oh, that's a little blurry, hey? See if we can get a better focus. There we go. Okay. And also, Braden, if you're watching, I saw your document. Braden Wheeler, if you're watching, I saw your document, and I've put a response for you in it. Okay, so there is our 24-meter rectangle. So one question you might ask is, once I knew this was 1 meter, how did I know this was going to be 11 meters? There's a few different formulas for doing this, but the one that I find the easiest is to just think about halfway around the rectangle. So starting at this corner, going up and then across and ending at this corner. Since the whole perimeter is 24 meters, half of the perimeter is going to be from here to here. So that's 24 divided by 2, 12 meters. So if this is 1 meter, well, I just do 12 take away 1, and I get 11. So if you take the full perimeter divided by 2, take away the width, you'll get the length. And we actually built this formula. You might remember a few days ago, we were doing rearranging of formulas, and we have the formula for perimeter of a rectangle is 2 times the width plus 2 times the length. And if you rearrange this formula for L, so let's subtract 2W on both sides. P minus 2W equals, well, 2W minus 2W is 0. 2L is all that's left. Now we want to divide everything by 2. You end up with perimeter divided by 2. This 2 and this 2 divide to 1. 1 times W is just W. 2 divided by 2 is 1. 1 times L is just L. And so you end up with perimeter divided by 2 minus the width gives us the length. And that's the formula I've used here. Perimeter divided by 2 minus the width gives me the length. And so in this case, perimeter is 24 divided by 2 minus the width, which is 1, equals the length. And that is 12 minus 1. So the length is 11 meters. All right, so that's how I figured it out. So this is one possible rectangle that has side lengths that are whole numbers and that has 24-meter perimeter. Another one, well, I could, instead of doing a width of 1, I could do a width of 2. Go ahead and tell me in the chat, if I'm doing a width of 2, what's my length going to need to be in order to get a perimeter of 24 meters? Take a moment, use the formula, or just figure it out in your head, whatever you prefer. What length do I need to get a perimeter of 2? Thank you, Owen. Thank you, Alan. Thank you, Adam. All right, so it is indeed 10. So 10 meters here, 10 meters here. And we can pretty quickly do the others. So if I have 3, then it's going to be 9 to get me to half the perimeter. And if I have a width of 4, I'm going to need 8 to get me to half the perimeter. And we're starting to get off the graph here, or off the paper. Let's keep going. So if we have a width of 5, 1, 2, 3, 4, 5, then a length of 7 will give us perimeter of 24. And I don't think I'm going to have enough room down there, so I'll do it here. 6, 1, 2, 3, 4, 5, 6. And that will give us 6. 1, 2, 3, 4, 5, 6, right to there. And then if I go up to my next one, which is 7, you'll notice something quite interesting happens. So you might be looking at that going, Mr. Island, that's just a rectangle. There's nothing interesting going on. Well, there kind of is, because this rectangle we have already drawn. We've already drawn it over here, and we turned it the other way, right? This is the first rectangle that's taller than it is wide. But if we turn that 90 degrees and we move it over, it's actually this rectangle here. So we've already got this rectangle. And if we go and we do the next one, which is going to be 8 tall and 4 wide, well, that's really just this one here. If we turn it, we're going to get 8 wide and 4 tall, and so on. So it turns out we don't need to worry about this rectangle or any of the other larger width rectangles, because we've already dealt with them here. We just need to turn these rectangles the other way. So there's no point in redoing all of these. Okay, so now let's go through and find the areas of these rectangles. And maybe you can kind of see visually that we're not actually going to get the same areas, right? These areas are larger than this one. So area of a rectangle is length times width, so 1 times 11. So this is 11 meters squared. This next one, length times width, 2 meters times 10 meters. That is 20 meters squared. 3 meters times 9 meters. Well, 3 times 9 is 27, so 27 meters squared. 4 meters times 8 meters is 32 meters squared. 5 meters times 7 meters is 35 meters squared. 6 meters times 6 meters is 36 meters squared. All right. So you can see that we do indeed have different areas on the various rectangles. Move it up so you can see that bottom one. And so now we can go ahead and fill in the table that is in the handout. So I'm going to move this paper here, make that table for you, and then we'll move back and forth between the two things and fill it in. So this table has width, length, perimeter, and area. And we did width 1, 2, 3, 4, 5, and 6, and 7 meters, 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 and meters. And then we know the width and the length together have to add up to 12, because that's half the perimeter. So we have 11 meters, 10 meters, 9 meters, 8 meters, 7 meters, 6 meters, 5 meters. Every single one of them has a perimeter of 24, which is why it's already filled in there for you on the sheet. And then we can go ahead and look at the areas that we've already calculated, or you can do the calculation straight up from this table. So here we go. So 1 meter by 11 meters, we calculated an area there of 11 meters squared. 2 by 10, we calculated 20 meters squared. 3 by 9, we have 27. 4 by 8, we have 32 meters squared. So 4 by 8 is 32. And I'll just go through and write the rest. 35 meters squared, 36 meters squared, and 35 meters squared. And so you can see that we peak here at 6 by 6 gives us the largest area for a rectangle with a perimeter of 24 meters. So what does this mean? This means that if you want to make the largest garden to contain the most plants with 24 meters of fencing, and you have to make a rectangle, the shape you should choose is a 6 meter by 6 meter rectangle. All right, what questions do you have about that conclusion that the largest one we can do is 6 meter by 6 meter rectangle? And if you don't have any questions, if you can just type a 1 in the chat. Great. Thank you very much. Okay, so now let's answer the questions on the worksheet that are just below the table there. So the first one is C, what are the maximum area? So the maximum area is 36 meters squared. Dimensions for that are 6 meters by 6 meters. D is asking us what type of rectangle is the one that gave the maximum area. That might seem like a bit of a strange question, right? Like triangles, we have isosceles and equilateral and so on, different types. But for rectangles, we don't really have different types. It turns out that's not quite true. We have an equilateral rectangle, but we don't call it an equilateral rectangle. We call it a square. And so a square is the type of rectangle with the greatest area. So you are welcome to repeat this. So usually when we've got everyone in class, we go through, we do one together, and then I give each of the groups a different perimeter to try out and to figure out which rectangle makes the largest area, so that you can experiment with a whole bunch of different ones. You're welcome to try that yourself. Pick any perimeter that you want and make this setup going. If the perimeter number you pick is not divisible by 4, then you won't be able to make a perfect square with whole number lengths. It turns out, though, that you can just take whatever perimeter you choose and divide it by 4 to get a decimal value for the square sides. And if you multiply those together, you'll see that you get a larger area than any of the others anyway. So you're welcome to try this out. But the rule that we're going to follow is that a square is always the rectangle with maximum area for a given perimeter, right? So if all the rectangles have the same perimeter, the one that's a square will have the most area. All right. So before we go on to E, let's write that as a conclusion here. Of all rectangles with a given perimeter, the square has the greatest area. All right. And this is actually true the other way around too, and we'll see that in a little bit. So question E is asking us, let's maybe put a star there because that's the most important thing we've learned so far. So question E is asking us, can we figure out a method for calculating the maximum area of a rectangle given its perimeter? So for example, if I told you the perimeter is 20 meters, what is the maximum area? Well, we know we want a square. If my perimeter is 20 meters, what's the length of one side of my square? So side length. Go ahead and tell me in chat. If my square has a perimeter of 20 meters, what is the length of one side? Right on. Thank you, Adam, Allen, and Emma. So we have a side length of 5 meters. And the way we get that is we do 20 meters divided by 4. So whatever the perimeter is, a square has 4 equal sides, so we divide the perimeter by 4. to get the side length. And then once we have the side length of 5 meters, what is the area of that square going to be? Go ahead and tell me in chat. Thank you, Emma. Thank you, Adam. Thank you, Alan. Thank you, Owen. It is indeed 25 meters squared. And I'm going to clear that out and just show the calculation first and then the final answer. So we take 5 meters, square it or multiply it by itself. And if you've ever wondered why a power of 2 is called squaring, this is exactly why. Because something times itself gives you the area of a square with that as the side length. So 5 meters is the side length. 5 meters all squared is the area of a square with 5 meters side lengths. All right. And so then if we put together what we've got here, we took the perimeter divided by 4 to get the side length. We squared the side length to get the area. So therefore, max area formula is going to be take the perimeter, divide it by 4, square it to get the side length. But here's a really important piece of math advice. You should not memorize this formula. The more formulas you memorize, the harder it is to keep straight which one is which and what they do. Instead, just go with what you know. Okay, I know if I have a perimeter and I'm trying to find a square side length, I just divide by 4. And I know if I have a square side length and I want the area, I just square it. So I can get from perimeter to the area of the square by just going through 2 steps that I already know. Don't need to memorize a new formula. All right, I will never ask you to give me this formula. Okay, so that is our formula for calculating the maximum area if we know the perimeter. I'm going to pause for a second there. Let me know in chat what questions you have. And if you feel like you are ready to move on, you can type a 1 in chat, please. All right, thank you, folks. So I'll keep an eye on chat in case people are typing questions. We're going to now look at F. F is asking us to use this. It says, use the method from part E, so what we just did, to determine the maximum area of a rectangular garden with a perimeter of 36 meters. So perimeter is 36 meters. What is the max area? We don't know. Well, we can figure it out. So max area is perimeter divided by 4, because that gets me the length of a side of the square. And then I square the side length to get the area. So in this case, perimeter is 36 meters over 4 squared. 36 divided by 4. Let me know in chat, what is 36 divided by 4? And then once you tell me what 36 divided by 4 is, tell me what that squared is. Thank you, Nina. Thank you, Owen. Thank you, Alan. So we do indeed get 9 meters all squared. And when we square our 9 meters, thank you, Owen and Adam, we do indeed get 81 meters squared. I'm sure your previous math teachers have told you, always make sure you include your units in your answers when you're dealing with a situation like this where it's practical and there are units. Okay, so you can see the first time through we did this, we didn't know the pattern. We had to look through, we had to make this big table, try them all out, see what can go on. Now we know the pattern, it's a lot faster. We go from 36 as our perimeter, and speaking of units, I should put them in, to 81 meters squared as our area almost immediately, right? We just write through the formula, boom, 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 calculated, done. All right. And we talked a little earlier what happens if you get non-whole number perimeters. That's totally fine. Exact same deal. So perimeter is 25.6 meters. Go ahead and figure out the maximum area for this. And once you have it, please type it into the chat. Cool. Thank you, Emma. Thank you, Alan. Thank you, Owen. All right. So we just do the same formula. Perimeter over 4 squared. In this case, the perimeter is 25.6 over 4, all squared. And if we calculate that, we do indeed get 40.96 meters squared, and that will be our maximum area. All right. So now we're going to move on to page 2, and we've got it in the opposite direction. In this case, we know the area that we need, and we want to figure out what is the rectangle with the smallest perimeter. This is actually the more common case out of the two. Both of them happen, but this is the more common one. So let's say that, well, in this case, it's a farmer who wants to fence a rectangular animal pen with the minimum amount of fencing. So let's say that this farmer has 9 sheep. The rules in Ontario for keeping sheep say that you need 4 meters squared for each sheep in your pen. So the farmer goes, okay, I've got 9 sheep. I need 4 square meters for each. So she does the calculation and she finds out, oh, I have 36 meters squared is the minimum area that I need according to the rules in Ontario. So I'm going to make a pen that has an area of 36 meters squared. And the farmer is going to make it rectangular because it turns out it's a lot easier to make rectangular fences than most other shapes and be sure that you have the right area. So let's flip this over. So the farmer goes, okay, 36 meters squared, that's my area. I want to know how much fence I need. And I'd really like to not spend more money on fencing than I need to, right? This farmer, oh, there, so you can see it. This farmer's like, I don't want to build a much longer fence and pay a lot more money. I want to build the shortest fence I can that gets me 36 meters squared of area. So what perimeter should I use? Well, we have a chart here again to fill in. And so I'll do it on the grid paper here for you. So if we want an area of 36 meters squared, well, I could start with a width of 1, and then I would need to make a really long fence. This might not actually, so this is not to scale because I don't think I have enough squares going this way on my paper. So it's 1 meter, 36 meters, not to scale. How do I know it's 36 meters? Well, I need an area of 36 meters squared. So 36 meters divided by 1 meter gets me 36 meters, or 36 meters squared divided by 1 meter gets me 36 meters. So if I have a width of 2 meters and I need an area of 36 meters squared, how long do I need to make this side? It's going to be longer than that for sure. Well, I go 36 meters squared equals 2 meters times the length. So if I divide both sides by 2 meters, I get 18 meters equals 2 divided by 2 is 1. 1 times L is L. So I'm going to need a length of 18 meters. Let's get a quick focus here. It's just off. All right. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So this one is to scale. 36 meters squared is 2 meters by 18 meters. And then I can do 3 meters. 1, 2, 3. Same process. 36 meters squared divided by 3 meters. I'm going to need 12 meters for the side length. So 2, 4, 6, 8, 10, 12. There we go. So this one also 36 meters squared, and that's 12 meters by 3 meters. And then, this blurriness is bugging me. All right. For 4 meters, do it up here. 1, 2, 3, 4. Well, 36 divided by 4 is 9. So there's 3, 6, 9. 3, 6, 9. And then 5 meters. 5 meters is an interesting one because 36 divided by 5 doesn't get us a whole number. It gets us 7.2. So it turns out we can't actually make a rectangle that's area is 36 meters squared with a width of 5 meters and a whole number length. We can do it if we take a non-whole number length, right? As long as we can do a 7.2 meter length, we're fine. But if we're just looking at whole number ones right now, we're not going to be able to do that. But for 6, we can. 1, 2, 3, 4, 5, 6. 6 meters. And 36 divided by 6 is, of course, just 6. 2, 4, 6. And so we get this one here, 6 meters. And just like our last question where we started with the perimeter, our next one up, well, 36 doesn't divide by 7. 36 doesn't divide by 8. 36 divides by 9. But if we make it 9 meters wide, it's going to be 4 meters long, and that's this rectangle here that we've already done. So from here on, we're going back through the rectangles we've already done. They're just going to be taller than they are wide instead of wider than they are tall, which doesn't make any difference because the farmer's going to put that rectangle anyway. Okay, so now we can fill in our table. So we have an area of 36 meters. We want to find the minimum perimeter. And we have the table here, and I'm just going to make sure I match up. So we have width, length, area, length, there we go, area, and perimeter. So our widths, 1 meters, 2 meters, 3 meters, 4 meters. You'll notice 5 is not in here because we found out we can't do whole number side lengths if we use 5. But we do have 6 meters, and then the next whole number one was 9 meters. All of them have an area of 36 meters squared. So I'll fill that in. And of course, it's already in the sheet if you're working online, so you don't have to worry about that. And then for our lengths, well, we're just going to do width times length gives area. So area divided by width gives length. 36 divided by 2 is 18. 36 divided by 3 is 12. 36 divided by 4 is 9. 36 divided by 6 is 6. 36 divided by 9 is 4. And so, like we talked about, 9 meters doesn't help us out much because it's just this same rectangle that we had at 4 meters. It's 4 by 9 or 9 by 4. It's the same rectangle. All right. So now we can fill in the perimeters. Well, perimeter is length plus width times 2. So 36 plus 1 is 37. 37 times 2 is 74 meters. Length plus width times 2, 18 plus 2 is 20, times 2 is 40 meters. 12 plus 3 is 15 times 2 is 30 meters. 9 plus 4 is 13 times 2 is 26 meters. 6 plus 6 is 12 times 2 is 24 meters. 9 plus 4 is 13 times 2 is 26 meters. And that makes sense because these two are the same rectangle, so they better have the same perimeter. All right, so what questions do you have about how we got these various rectangles and made this table from the information that we got from the rectangles? So I'll give you a few moments. If you have a question, put them up in chat. If you're feeling pretty comfortable with how all of this worked out, go ahead and give me a 1 in the chat, please. Thank you, folks. Okay, so I'll keep an eye on chat. If you have a question, please put it in there. You can see once again, especially if we look at the table, the one with the smallest perimeter and the one that the farmer wants, because the farmer wants to spend the least amount of fencing. She'd rather buy 24 meters of fencing. She doesn't want to buy 74 meters of fencing. That's like 3 times, more than 3 times as much fencing. So this fence, or this 36 meter square area fenced section would be 3 times as expensive to build as this one. So the farmer doesn't want to do that. She wants to do this one here. So 24 meters of fencing is the shortest amount that she can use. All right, so now if we start answering the questions, C, 24 meters is the minimum perimeter, smallest amount of fencing, smallest perimeter. And it's 6 meters by 6 meters to get us 36 meters squared. And you notice once again, the square is the one that's best. So if we're building this rectangular area and we know what the area is, the perimeter that's going to be the smallest that contains that area is going to be the square. So D, it's a square. E, well, now we have to work backwards a bit. So we know the area is 36 meters squared. And this sometimes people find a little tricky. How do I get the side length of a square if I have its area? So if I know there's a square with 36 meters squared, how do I find the side length? Go ahead and let me know in chat. How do I find the side length for a square that's 36 meters squared? All right, so this one is a little trickier. We've got a few different ways we can go about it, but one of the easiest is to pull on a skill that we already have, which is rearranging formulas. So in the previous question, we were figuring out the area given a perimeter. And we said you take the perimeter, you divide it by 4, you square that answer, and it gives you your area. Well, if we take this formula and rearrange it to give us the perimeter, because this is a formula specifically made for squares, right? Take the perimeter of a square to get the area of a square. So if we have the area of a square and we want the perimeter, we just need to rearrange this formula. So I'm going to do that. I'm going to undo a square by square rooting. So square root of p over 4 squared. And square rooting a square undoes it, like in Pythagorean theorem. So we end up with p over 4. And then to undo a division by 4, I'm going to multiply by 4 on both sides. And so I eventually end up with my perimeter is equal to 4 times the square root of my area. So perimeter equals 4 times square root of the area. Now, does this formula make sense? Well, yes. If I have a square whose area is 36 and I want to find the side length, I square root that. So one side of this square, 36 square rooted, let's plug it into a calculator. Square root of 36 equals 6. So that tells me one side of the square is length 6. And then if I take that and I multiply by 4, I'm going to get the full perimeter of this square. So here we go, 4 times square root of 36 meters squared. That gives us 4 times 9 meters, or sorry, 4 times 6 meters, pardon me. 4 times 6 meters is 24 meters. And so that is the smallest perimeter that we can have. All right, give me a 1 in chat if that's making sense. And if you have questions, now is a great time to ask them. Thank you, Emma. Thank you, Owen. Thank you, Alan. All right. So we've dealt with the situations where we're building a rectangle. We know that a square is the most efficient. If we have a perimeter, a square will give us the biggest area. If we have a given area, a square will give us the smallest perimeter. So our efficiency there is found in squares. There is one other situation that we're going to look at, and that is the situation where we are building a rectangle, but we're not building all 4 sides. So in this case, maybe you're building a rectangle on the side of a building that already exists. So maybe there's a daycare building, it's got a door here, and you want to build a playground fenced in so that none of the babies can wander away. You're not going to build all 4 sides because you have the wall of the daycare here. You're only going to build 3 sides. All right. So in the interest of time, we're not going to go through and make up the full chart and draw them all out. I will just tell you that the length and the width here, the width, which is the side of which there's 2 of them being built, is going to be half the width. So, half the length. So if this is L and this is W, then L is equal to 2 times the width, or W is equal to half the length. All right. So this is for rectangles where only 3 sides are being built. a length that is twice the width is optimal. So let's do one quick example with that. So as an example, let's say we have a perimeter of 40 meters and we want to build the largest fence that we can with those 40 meters. But we're only building on 3 sides. So we want to find max area, 3 sides only. So it turns out that you can think of this like a square. I know that seems a bit weird, but if you imagine, I'm going to get a different color here. If you imagine halfway down this length here, and you cut right there, and you take this section that I'm highlighting in red, and you turn it, you hinge it around this point so that it comes down like this and like this. So you basically like move it in there. Well, once you do that, this is the width. This is the width because it's that piece moved in. This is half of the length, but the length is twice the width. So half the length is the width. And this is also the width. So you can think of this shape in some ways as the width on both ends, another width here, and a fourth width here, joining it to make the length. So you still need the width to be 1/4 of the full perimeter. So the width is going to be perimeter over 4, which is 40 meters. And that is calculated exactly like what we did before. So 40 meters. So we get a width of 10 meters. And the length is twice the width, which is twice 10 meters, which is 20 meters. And then the area, well, that's just going to be length times width because it's a rectangle. So 10 meters times 20 meters, 200 square meters. All right. What questions do you have for me about that? So type them out in chat. If you're feeling confident with this, you don't have any questions, give me a 1 in the chat, please. Thank you. Thank you. All right. So I'll wait around for another few seconds. If anybody has questions, feel free to put them up there. The homework today is out of the textbook, page 460, number 3 and number 6. And those ones are situations where you're making all 4 sides of the rectangle. And then on page 461, numbers 1 and 6. And there we have some examples where you're only making 3 sides of the rectangle. All right. Have yourselves a great rest of your day, folks, and I will see you again on Wednesday.